Okay, now here's a really neat theorem that actually we already know is true by our previous results. Let me show you the theorem, and let's see that we already know that it has to be true. The theorem states that a quadrilateral, so that if we have a quadrilateral that's inscribed in a circle, so that just means that I've produced a quadrilateral where all the vertices actually lie on the circle, then its opposite angles are supplementary. That means that the measure of this angle plus the measure of the opposite one must equal 180 degrees. And similarly, the measure of this angle plus the measure of that angle must equal 180 degrees. Why in the world should that be true when you draw in any quadrilateral at all inscribed in a circle? Well, we already know the answer. This can be viewed as an inscribed angle with this as its arc. That means the measure of this angle is half of the measure of this arc. Now, keep your eye on the arc. In fact, I'm going to sweep out that arc with this hand. Do you see it? Okay. Now look at the opposite angle to this. That's the angle B. But notice that angle B actually comes from this particular inscribed angle, swept out by which huge arc? This arc here. So therefore, I know that the measure of this angle is going to be half of this arc. But look at that arc. I can't even grab it. But that arc is the stuff that's left over. So therefore, I know that this measure is going to be half of this. This measure is half of this. So together, I get the whole thing, which is 360. But these are half of that, which is 180. So in fact, you can actually see why the sum of these two angles have to be 180, similarly for these two. And so in fact, this really is a theorem which we just proved. Ha! Now, jujitsu-like. Okay, now, let's take a look at an example. So here we've got this quadrilateral randomly drawn in, but it's inscribed in a circle. That means that all the vertices actually touch the circle. And we're given various things. For example, if the measure of this is 10x minus 10, then this is 13x plus 3, and this is 11x plus 1. We don't know anything about s. And you know what our job is? Our job is to actually find all the measures of all the angles. Wow. How can we possibly do that? Well, we use this great theorem we just discovered. Namely, we know that opposite angles of the quadrilateral are going to be supplementary. They add to 180 degrees. Well, this pair of opposite angles, not a great pair to consider since I don't know anything about s. But this pair of opposite angles, much more fruitful. If we take a look at them, what do we see? What I see is that this plus this has to equal 180 degrees. So what do? Well, if we add these two angles up, here I see 10x plus 11x, and so I see 21x. And if I add the 1 and the negative 10, I see minus 9. And that has to equal 180 degrees. And now I can solve this. If I add 9 to both sides, I see that 21x equals 189 degrees. And if I divide both sides by 21, I see that x equals 9. Now that's not the answer. I'm supposed to find out actually the angles. So let's do it. If x equals 9, we have to plug in. So we plug in here, and we get 10 times 9, which is 90, minus 10 is 80. 80 degrees. What about up here? Well, I could plug it in, but I don't have to. I know that they're supplementary. So they have to add to be 180. I've got 80 here. That means this has to be 100 degrees up here. What about here? I plug in 9. I see 13 times 9. I add 3, and I see 120. And s, which I didn't know anything about at all, has to be the angle that I add to 120 to make 180, so it has to be 60 degrees. We found all these wonderful angles using the amazing structure of the circle. I love it, and I hope you do too. I'll see you soon.